So I'm going to continue now with our trick to help you to understand another very awesome question. This one is probably one of the questions that will definitely give you challenges if you had it in the exam. It's what we call a problem-solving question, where you never know where to begin to get the answer on this. So let's jump right into it and help each other to understand how do we analyze it. Right. So let me see what the story is here. We are told here that it is given that x equals cos 0 plus cos 1 degree plus cos 2 degrees plus cos 178 degrees plus cos 179 degrees plus cos 180 degrees plus 2, and y is 8 cos a cos 2a divided by 2 cos cubed a minus sine 2a sine a. And the instruction here is we need to show that x is equal to the square root of y in cases where y is defined, right? Now, it's important for you to understand two things when you're working with this. First of all, when we say we want you to find the answer where this thing is defined, it means that sometimes the y value might not come out because the denominator becomes a 0. There's options for that. You might have that situation. That's why that statement that says where y is defined is important. But this one is a question that has two parts, the left-hand side and the right-hand side. We're required to show that the left is equal to the right. So what we are going to do, we're going to simplify the left-hand side, which is x on its own, and then we're going to simplify the right-hand side, which is y on its own, and see at the end if these two things really look the same or not, right? So let's see what will happen if we do that. So I'll begin first of all by putting x and saying x is given to us as 0 degrees plus, not 0 degrees but cos of 0 degrees, right? X is equals to cos of 0 degrees, which is cos of 0 degrees. Cos 1 degrees is also added there. There's cos of 1 degree. Cos of 2 degrees, there's cos of 2 degrees plus. There's a lot of stuff going on there. And then now we're going to have cos of 178 degrees. But now this 178 degrees, it is an angle in the second quadrant, guys. Very, very important for you to keep that in mind. 178, even 179 are all angles that lie in the second quadrant. So like I said before, we don't like dealing with these big numbers. So we will try and reduce that by rewriting it as 180 minus something. And you will agree with me that 178 can be expressed as cos 180 degrees minus 2 degrees, right? And then the next one is cos of 179, which can also be expressed as the cosine of 180 degrees minus 1. And then I'm given cos 180 degrees, which is a special angle. We know how to find the cos of 180 degrees, and this has to be added with 2, right? So if you simplify this further, as far as x is concerned, you're going to get cos of 0 degrees, which is simply equal to 1, plus cos 1. We don't know what is cos 1 without a calculator. We also don't know what is the cosine of 2 degrees without a calculator. But something interesting emerges once you start looking at stuff like this. Because if you are dealing with 180 minus, that's the second quad, and in the second quadrant, cosine is negative. So this is going to give us a negative cos of 2 degrees, right? And then even the second part as well, this part of cos of 180 minus 1 will simply also do the same thing. It will give us the cosine, which is also negative since that's the second quad. It's going to be cosine of 1 degree, right? And then we've got plus the cos of 180 is negative 1, and that has to also be added with a value of 2 at the end. I hope you guys can see what is going on there. Right, and then if I simplify further here, you will notice something very exciting. 1 is a number, we are writing that, but cos 1 is positive, and there's cos of minus cos 1 on the right hand side, the far right. Those are simply going to cancel each other. This deletes that out, and even the cosine of 2 degrees will delete the cosine of 2 degrees, and then I'm left with minus 1 there. That minus 1 happens to also delete that 1 I'm looking at there, which I could have just written, it's 1 plus that negative 1 plus 2, which just simplifies to exactly 2. And this is what we are getting for x, right? Now we're going to the next part here. We're going to the next part, which is the value of y. We just found what x is. Now we need to simplify what y is. Y is 8 cos a cos 2a. So let's get that. We need to show that even the square root of y is going to give us the same answer as what we got for x, right? So according to this question, y is 8 cos of a cos of 2a divided by 2 cos cubed a minus sine 2a sine A. Let's just see that we got the same thing and we're not making a mistake as far as that is concerned. Yes, it's sine 2A times sine A. That's actually what you have. So we need to simplify this and prove that what we're looking at here will just simply give us a value of 2 as well. Now on the numerator, I've got a double angle of cos. Every time you see a double angle of cos, guys, you need to chill. Don't rush. We don't know what is going on here. Wait. Just wait. You don't know what is happening. So don't rush. Leave it there until there's more information that can help you to understand what you need to work with. But there's a victim, an all the time victim, which is the double angle of sine. This one, we can always simplify it, and we're going to start with it by finding the value of the double angle of sine and see what we're going to end up with here. So I've got 8 cosine of A multiplied by the double angle of cosine. I don't know which version to pick because it's got 3 versions, I think. So we don't know which one to pick at the moment. So I've got to cos cubed of A minus. Now you're looking there, you see something very exciting, which is the sine of 2A, which can be expanded to 2 sine of A cosine of A, and then there's sine of A also at the end there. I'm going to also keep that following us. And then if you simplify further, you get 8 cos of A multiplied by the cosine of 2A divide by 2 cos cubed A minus, look at something very exciting here, cos A is actually a common factor. If you look there, inside this, I can get cos A and a 2. Even inside the second part, I can get 2 as well as cos A. So that 2 cos A is simply a common factor, which I am going to now factor out because I noticed that, hang on, we do have a common factor. So I'm going to take out that 2 cos A out. On the first term there, I'm left with just cos squared A minus. 2 is out, cos A is out, sine times sine gives us sine squared A as well. And if you simplify this, you will notice that you are left with 8 cosine of A cosine of 2A divided by something. What is something? You are left with 2 cosine of A, and this, beautiful people that you're looking at there, is a double angle. All this is the double angle of cosine. Like I told you, chill, because this is actually cos 2A, which we are going to write as cos 2A here. I'm going to write cos 2A, and this cancels that, and this cancels that. 8 over 2 is simply 4. So y comes out as 4. If you take out the square root of y, you end up with the fact that the square root of y also happens to be the same as what we got, which is an answer of 2. Therefore, x is indeed equal to the square root of y, and that is the solution to the first part of the question. I hope you saw how you had to do that. It's very important for you to understand when you've got 2 things, you need to show that they're the same. You can work on the left-hand side, work that one until you find an answer. Take the second part, work on it until you find the answer, and then compare them to see if they're giving you the same answer. Right, now we're moving on to the last part of this question. If you come to this one and you check what is going on here, this will be the last question that we have for our show today. We are told that we need to determine the general solution of 2 cos x equals to the sine of x plus 30 degrees. Now, we've learned a lot about the expansion that you're looking at right there. We need to expand it and then see what is going to happen. So I'm left with 2 cos of x equals the sine of x plus 30 can be expanded to the sine of x, the cosine of 30 degrees plus the cos of x and the sine of 30 degrees. Right. This means that the cosine of x equals to the cos 30 can be written as the square root of 3 over 2 multiplied by the sine of x plus the sine of 30 can be written as a half multiplied by the cos of x. I don't like all those divided by 2's that I see flying around everywhere. So what I'm simply going to do is I'm going to say everything I have here, I'm just going to multiply it by 2. I want everything to be doubled because I want to get rid of those denominators. So if you double 2 on the far left, you get 4 cos of x. If you double this, you get a square root of 3. Sine of x, if you double half, you get 1 cosine of x. Right. Now, if you proceed further, we can see that cosine is appearing on both sides. I want to add like terms. So I'm going to subtract cos x on the left. I'm also subtracting cos x on the right hand side. What you do on the left, you need to do the same thing on the right hand side. I'm left with root 3 sine of x, and then that is going to be 3 cosine of x. Right. Now, this looks like something that we can simplify because if you've got different ratios that have the same angle, we can use the tan identity. So I'm going to divide this by the cosine of x and divide this side by the cosine of x. That cosine is gone. You're left with 3 equals the square root of 3 sine of a cos is just simply tan of x. So this means the tan of x is 3 divided by the square root of 3. Right. When you are here, it's just a matter of finding what we call the reference angle, because they're asking for the general solution. Arctan fraction, you've got 3 divided by the square root of 3. It gives you exactly 60 degrees, which is your reference angle. So I'm going to say my reference angle is 60 degrees. Therefore, my answers are going to come where tan is positive. Tan is positive in quad number 1. Tan is also positive in quad number 4, not 4 but 3. Yes, quad 3 and quad 4. Remember, all are positive here, tan is positive there. Right, and then I'm going to say, okay, in the first quad, your answer is what you're looking at. So x equals to 60 degrees plus k times 180 degrees because we are dealing with tan. Or in the third quad, x is 180 minus that. Let's just see that. So 180 minus 60, 180 minus 60 gives you 120 degrees. Not 180 minus, but 180 plus. Third quadrant, guys. Third quadrant. That's 240. Beautiful stuff. So we're going to have 240 there. So this is going to be 240 degrees plus k times 180, where k is the element of integers. Very powerful stuff right there. I hope you guys understood what you had to do. It's very important for you to convince yourself that when you're working with these kinds of questions, you understand how do you analyze them. First of all, which identities are going to be very useful for you to try and find the answer to that particular question. And then you understand how to also be able to find the answers to anything that is expanded. You need to be able to compress it. If it's compressed, you need to know how to expand it.